Bueno, buenos días. Lo primero, daros gracias por venir y atender esta sesión con nosotros. Mi nombre es Asier, mi compañero es Arie. Esta sesión va a ser más o menos a la mitad en inglés. ¿Algún problema? ¿No? Vale. Damos gracias también a los colaboradores y a los patrocinadores. Sin ellos este tipo de evento no tendría lugar y pues, es un sitio bastante bonito donde compartir experiencias. Compartimos experiencias desde nuestra parte como clientes y bueno, os vamos a hablar de cómo desde el caos empezamos a organizarnos y cómo hemos llegado a un balance en nuestros consumos de Azure.
So I'm working at V Global as a cloud engineer specialist or cloud system engineer. We never know what to put really for a name. And together with the operations team, we support everything related to our cloud infrastructure. So that's me.
Ahí va. Bueno, yo soy el Cloud Infrastructure Leader para V Global. Con Arie, pues bueno, lideramos un equipo de operaciones donde, pues bueno, llevamos todo lo que es el tema de Azure, continuous deployment con desarrollo y llevamos toda la infraestructura de producción y desarrollo de nuestros sistemas. Tenéis también, tanto como Arie como yo, nuestro LinkedIn, por si queréis contactar con nosotros, hacernos alguna pregunta, pues nada, libres de contactar y bueno, os escribiremos lo antes posible. Bueno, esta va a ser la agenda. Pues bueno, vamos a hablar del dinero, de cómo usamos nuestros servicios en Azure y bueno, os daremos unos cuantos tips de cosas que hemos ido haciendo y cómo hemos conseguido ser más valiosos de cara a la cara de nuestros financieros. ¿Y otro? Bueno, V Global es una empresa que empezó en 2010. Y en 2014, pues bueno, nos llegó las decisiones de la transformación. Hasta ese momento operábamos en 3 zonas geográficas, en Asia, Europa y en Estados Unidos, con 90 servidores en on-premise, en datacenters convencionales. En 2015, con la transformación al cloud, pues bueno, le pegamos fuerte y fuimos con 800 servidores directamente y 260 servicios Performance as Service y otros servicios clouds, como pueden ser en Amazon y Google, de unos servicios externos que utilizamos. En 2016, bueno, la pegamos fuerte, fuimos con 1.500 máquinas como infraestructuras as Service, 430 servicios como Performance as Service y bueno, subimos un poquito en servicios de otros providers. Y en 2017 empezamos lo que fue el gran proyecto para nosotros, organizarnos y empezar a reducir nuestros costes. A final de 2017 terminamos con 1.200 servidores y unos 300 servicios Performance as Service. Y bueno, con lo que os estamos contando y lo que os vamos a contar y nuevas acciones que vamos a hacer, esperamos terminar este 2018 con menos de 700 servidores como infraestructuras as Service y menos de 270 servicios Performance as Service.
working, please let me know. The first question I want to make actually is, who finds itself in the position that he thinks he doesn't control his cloud costs, really? Like, are there more people like us that at the point where we were? Like, I think there are more people, yeah. So that's good to know at least. Then we're doing it for a good reason. The first article I want to start with is based on a survey from from RightScale. Too much corporate money is evaporating into the cloud. They did a survey amongst a few big companies, and what they found out was that most of the companies are spending or overspending 30 to 35% of their cloud costs. So they're misusing their money for underutilized services. That also brings me to the next one. What's behind the overspending of cloud services? And that's also what we will talk about right now. So how come that you spend too much, or you don't know where your expenses go, or why do you pay 50,000 euros each month, or more or less, what it is, for the few servers or the services that you have, of course. So what we want to do is to show you our chaos that we started with, at least that has been explained already, the chaos that we had in 2016 when we had a massive growth of infrastructure. So we really went from the 800 virtual machines in 2015 to 1,500 virtual machines in 2016. We grew really massively in our cloud costs until at one point they said, this cannot go on longer like this because we're losing track of our cloud costs. And that's when we started what I like to call it a cloud optimization project. At the end, it's just a cloud reduction, cost reduction project. Which side? This one. It works. And for us, it starts with track your money. So where does your money go? How can you get reports? How can you get all your services and all your virtual machines and everything? How can you get more insights? And how can you set up, for example, alerting tools? So what we started to do was to look into a cloud tool, management tool, to see if they could help us finding the right way to get reportings on track, to get more insights, and to get the end of the month report that we need to hand over to management every month done in a quicker, in a swifter way. So we found Cloud Health after researching different options. So I think we've been checking HANU Insights, Cloud In, and more options. At the end, we thought that Cloud Health was the best fit for us. It's a bit strange because you want to do cloud like a cost reduction, and then you start paying someone for a management tool, so you need to pay a percentage over your cloud cost to them also. So yeah, are you really going to believe them, or are you going to do it, or are you not going to do it? At the end, it worked out really well, because the normal reporting that we, for example, did was like we had to take a whole week off just to download the CSV from Microsoft. I don't know if you've ever done it from the enterprise agreement from the portal. You download the CSV, it's 300,000 lines, 300,000 rows. You need to select a filter, you make a pivot table, you enter in tags, and then you drag out your final cost based for one team. And then you spend 1 hour, and then you have another 10 teams to go. So that doesn't really solve a lot. So at the end, what we did was, together with this tool, we set up a range of tags and perspectives, which has helped us a lot in the reporting, which I will show you later also a bit more. Besides this, we could also set up alerting here. So what we have been doing there was setting up a configuration which alerts us when our cloud costs on a daily basis grows with 5%. So when your cloud costs go up with 5%, we receive an email, we can take an action, and we right away see where, in which category we're going up in our cloud cost. And of course, then after that, it's digging down a bit deeper inside that category to see where your raise is coming from. But this is a good way, at least, to keep track of unexpected raises in costs. And why do you have these raises in cost is another question that you can ask yourself, of course. One of our problems was that management had given a lot of freedom to the developers. You don't really want to cut their wings, their new fancy toys. It's the cloud, so let's play. Let's be like a second Google. Give them the freedom. They feel more valuable. They feel that they're touching nice toys. But at the end, you also need to keep the cost perspective in mind there, which is really important, of course. Besides this, you can also create your own tool. You can use the Azure API But then you have to deal with the last point here, which is the maintenance, which also takes a lot of time, which generate costs. So this is what I was talking about. Here we have I forgot it in the middle, as I can see. Here we have the policy set up. So if the daily cost increase more than 5% in whatever Azure subscription, then an email gets sent automatically to the operations team in this case, and we can take action. You can set it however you want, of course. You can choose 5%, 10%, 1%. You also need to keep in mind that normally over the weekends, in our case, for example, we shut down our environment, so maybe there's a different behavior there, of course. Then you always have the 5% of difference. Let's go to the next one. So after using the management tool that we had, we started tagging the resources. We found out that we did get our reports done quick enough, so we could go to the management tool. We could click with one click. We could see our monthly expenses or our daily expenses. But who was really responsible for those expenses? Like maybe it was team A, maybe it was team B, maybe it were all the teams together, maybe it was just one programmer who spun up a DocumentDB resource or whatever. So we started to tag everything. This is when we introduced the team tag, the cost center tag, and a product tag. The function area tag came later. At least to see which team was responsible for which cost, and also based on cost center, we could divide it right away for management in cost center. So we could say the team responsible for this product, the team responsible for product A, for product B, or just the operations team, for example, or whatever other team that there is responsible for these costs. Later we came with the idea to create the function area tags, which in our case is based on big data, for example. So we have a function area which calls data ingestion, data processing, then our different products we have there also, then we have infrastructure, we have databases. So there we started playing a bit more, and we started taking away the team tag. So what we did was think, prep, tag, really think clearly about which kind of tags you need, because you can create 500 tags, but you only might need 2 or 3. Prepare them, prepare your people, your developers also, because they need to set them up. In our case at least, we make them make their own pull request to ARM to push the tags automatically to our environment. And like that, we tag our system. This is not just interesting. I want to highlight this. This is not just interesting for the cost view, for your cost reporting, but it's also really interesting for yourself, because you can make PowerShell commands, for example, based on the tags. So you can select everything containing a certain tag, and right away reach that group of machines or resources containing that tag. So you don't have to depend on other filters that you want to use. So then we go to the next part. This is called govern your money. So what we do here was actually, we want to show you how which actions we took to lower our costs. So we got the management tool. With the management tool, we could see where our money was going, which team was responsible, and of course the flow of money, like the how do you say it? The timeline of the money. So maybe we spend more in certain weeks, maybe we spend more on Black Fridays, the weekends are different. And what can we do with that? So be smart, reduce your costs. So here we started, we had the management tool in place. The management tool also gave us another option, which is the right sizing part, where you can see which VMs, which resources are underutilized. So here we could also right away find the old resources. The old resources were the ones that were the test ones. Normally they were running around 1% of CPU or lower even. So those I also put under the color of old resources. The old resources, normally people create a resource, they go to the portal, they have the power, so they create a resource, they call it test Arie, for example. You forget about it, or you just delete the virtual machine and you forget about your disk, for example. It's a really good one just to clean them up and to have your environment clean. So right away, question here. how many old resources are there in the environment? What do you think in percentages seen, old or test resources in this case also, could there be? If there's a number, 10%, 5%, 20%, 50% even, I don't know. Any thoughts from people? 50% of unused old test resources. From another article that I read, it's just a research that was done, they also said that it was like around 35% of resources that are test resources, old resources that are running, but they can actually be combined with different resources on different virtual machines. They are underutilized, and they are really in need of a renewal or of an update of code in this case. So they also went to 35% of this. So the 50 is not that bad, but it's really, and for me it's really shocking that there's such a big amount of underutilized and wrongly used resources. What we also did was a programmed cleanup we set up. So we have our development subscription, for example, and we have something, a script running there, which checks the age of the resources, and based on the age, it deletes them automatically. If people want to have those resources for a longer period of time, they should create them in another in another subscription, sorry, where we need to approve the pull request for, of course. So then it's in our hands, and we have the maintenance and we have the control. Now then we have a part, what I said before also, the storages and VHDs. Always when you delete your virtual machines, delete everything that comes with your virtual machine, your availability set, your IPs, your network parts, and your storages also. Your storages, a lot of time people forget them, and the VHDs keep on running there. And then at the end, you have a whole subscription or a whole environment full of storage accounts that are not being used, they're not connected, they do not have a lease, and you pay a lot of money for them, especially in the old versions where you could only choose, I think it started with 500 gigabyte disks. So here, for example, I put a script of the TechNet website, which you can download. It's a script that checks your subscription on the lease status of the VHDs. So you can see if it's connected or not. If not connected, it's not being used. Maybe you're using it for a backup, so do filter it before you start deleting. That's a smart one. And another one in the same area also of storages is the managed disks. So here, this is the same. These are disks that are just growing with the usage that you need them for. So if you need 10 gigabytes or you need 50 gigabytes, you will grow little by little with the usage that you make. You don't have to buy that 500 gigabyte disk and pay for 500 gigabytes where you're only using 1 gigabyte, which happens in a lot of cases. Use the managed disk, you install it, and automatically it will grow and it will expand. And you're only paying, of course, for the gigabytes you're using. The last one I put is code optimization. This involves a lot the development teams also. So this depends on the traffic, for example. In our cases also, we have some clusters that are really depending on the traffic. If you have something that's responding in 5 seconds, then why not making it respond, do some code optimization and make it respond in under a second, for example. Like this, you take a lot of load from the machine, a lot of stress from the machine, and maybe you can even lower the size of your whole cluster, of course. That for cleanup and optimization. Auto shutdown. As we've practiced a lot of times, the auto shutdown, for the 3rd time I'm saying this in this week, I think this was my favorite one because it was the easiest one in the sense after fixing the script. You can do this with a runbook. There are runbooks in the automation accounts, I believe, is the category in the portal. There are some runbooks that are already programmed. Normally they're based on PowerShell also, which shut down your environment or different resources and starts them up in the morning again. So it shuts them down in the evening, whenever you want to, and it starts them up again in the morning. In our case, we created a custom script based on our tags, and what we did, there it is. There's another tag. We created another tag, which is the auto shutdown schedule tag. So here you can see that at 8 o'clock in the afternoon, 8 o'clock in the evening, this machine, this specific machine, will shut down, and it will be deallocated. You need to deallocate your machines for the cost to be, for it to stop generating costs, to say so. At 4 o'clock in the morning, it will be started again, also because due to time zones that we have, We need to start it on time because we work in different time zones. So 4 o'clock here is maybe 6 o'clock or 7 o'clock somewhere else where they already starting to work. So in this case, as you can see, for example, if you would stop it at 7 and you start it the next day at 7, you're saving 12 hours of cost that you don't have to pay because you pay per minute. So like this, you generate a lot of cost reduction. The whole Saturday, the machine is stopped, and the whole Sunday is stopped. Where do we use this? In the development subscription, and then we also have the CI subscription, the continuous integration subscription, and this is where you can use this perfectly. If you want to use it in production for certain areas, it's a bit tricky, so be careful with that. That's what we found out at least. But there you also you can also use different options there. We have our script running in a web job. It runs every 30 minutes, so every half an hour people can shut down machines based on the tag that you give to them. That's it. Yeah, why did we create actually a custom script? Because we found out that in that time the runbooks were shutting down all the machines one by one. And I don't know if you've ever clicked the button of stop a virtual machine, and then it takes and it takes and it takes before it really says that it's deallocated. It takes really long. So we had certain time periods, like at 7 o'clock or 8 o'clock, which are our busy periods, that 20 machines had to be shut down. So the last machine would be shut down 2 hours later. That's not really a problem when you shut down, but in the morning when you come to work and you want to start working on a machine and it comes up at 11 o'clock, that's a bit too late. So we had to create our own script and make this run parallel for all the machines. My last slide, right sizing. So this we can do with the cloud management tool that I told you about before, the cloud health tool that we're using. They have a module there that is for right sizing. So in this module, the system is giving a score based on CPU, memory, and disk usage. So if your CPU, if it's running lower than 20%, it gives a lower score. Then if the disk usage is not being used well, it gives even lower score, and of course also based on the RAM memory, depending on the usage of that. So it gives a score between 1% and 100%. 100%, then you have a perfectly balanced machine. Actually too balanced because it would be too used maybe in that sense. What we do is we filter everything out under 20%, and like that we catch a lot of machines that are not being used. We find a lot of machines that are only running on 2% of the CPU, 5% of the CPU, 10% of the CPU. Well, virtual machine can easily run on 40% of its CPU because then you're using it optimal. So you really need the right size. With this tool, we can also, of course, lower down the size of the virtual machine. So instead of using a D2, we can go to a D1. In some cases, you can even start playing with combining different APIs or different applications that you have to put them in the same cluster or in the same set of machines. Then we created also a custom tool. That's this one. It's written in C# by one of our programmers. It does exactly the same, actually. The only thing is that we're not depending here on our management tool. And we created this because there we can also create it by a cluster view. So what we can do is we can select the subscription in the first one here. I don't really like the red dot. So here you can select the subscription. You can select the days to analyze. You can run it, and it will give you all the machines with the CPU load. So the CPU load based on the average CPU max, the minimum, and the CPU total. Based on the uptime. So if the uptime, some machines of course are being shut down in the night, so they have less uptime than other machines of course. So it's based on the uptime. Now the machine size is being put here and the resource group. So what do we use it for? We use it for the cluster view, as I said. So what it does, it grabs all the machines that are that contain the same name, because our naming conventions are based on groups of machines. And like this you can see which clusters are underutilized and take action to it. So based on the CPU, also here, we work with colors. When the machine is in red, it's not being used well, so we start taking actions. And like this, we reduce our cost pretty much. The last item on my list is the new machine series. Of course, you know that Microsoft introduces a lot of different machines every now and then. They started with the V2, which is a lot cheaper than the V1. It gives you 35% more processor performance, and the cost is lower than the V1 version of the D series, for example. Nowadays, you also have the V3. The only thing that changes in the V3 is that the hardware is not exactly the same as the V2, what they offer you. And of course, you can also, for example, nowadays go for the B series, which are the burstable machines that work based on credits. They're really interesting. Watch out in production, I would say, because at the moment that you spend all your credits, it will go back to 10% of the usage based on the CPUs that you're using. I don't know if someone has been next door before, but Daniel also explained it before. So what the B series do is, based on the CPU, if you're using less than 10% CPU, it starts generating credits to a maximum of an amount of credits. And when you come above the 10%, you start spending those credits. But if you have a system that, for example, is saving credits for only 8 hours and it's running high on CPU usage for 16 hours, then you will not make it. And it will fall back to under 10%, while the machine might need 50% of its CPU power. But they're a lot cheaper. I think they are 30% cheaper than the normal virtual machine compared with the same specifications. I think that's it for my part, actually. A lot of talking.
Gracias. Bueno, después de todo esto que ha explicado Arie, redujimos bastante nuestro consumo, pero aún así veíamos que podíamos hacer algo más. ¿Y dónde fuimos? Pues primero a analizar qué es lo que hacíamos mal. Muchas de las veces utilizábamos cosas en preview, no mirábamos los precios y íbamos a global available en producción y el siguiente mes pues nos pegábamos la sorpresa de ¡uf! ¿Qué hemos hecho? Otra cosa que hacíamos mal es sacar precios directamente de la calculadora. Si eres un cliente de Enterprise Agreement, pues posiblemente tengas diferentes precios. Una cosa nueva que han metido en la calculadora de Azure es que si estás logueado en el portal puedes sacar directamente tus precios y hacer ya la calculadora con todos los datos que necesites. Y otro de los puntos que teníamos mal, y bueno, todos somos héroes en nuestras organizaciones, todos vamos liderando cosas, queremos hacer cambios. Y en nuestra organización, por ejemplo, esto nos llevó a un camino incorrecto. Fuimos a ciertos servicios de Platform as a Service y bueno, derrochamos un montón de recursos, de tiempo y al final no nos llevó a ningún sitio. Y tuvimos que volver a lo que teníamos anteriormente. Aparte de eso, analizamos un poquito más y bueno, vimos que había tajada con las máquinas virtuales, con máquinas virtuales que están con más de 2 máquinas en una availability set. Probamos los virtual machine scale sets y bueno, tenemos un futuro que está cerca y es que nos vamos a containers. Con las máquinas virtuales, pues en este ejemplo que tenéis aquí, estamos corriendo unas 15 máquinas virtuales. Es tráfico que tenemos en producción y bueno, básicamente lo que veis ahí en rojo es que estamos derrochando computación, tiempo de computación. Bueno, viendo cómo actuar, pues se nos ocurrió una cosilla y es pues ir a ver las métricas y los diagnósticos que nos ofrece el portal de Azure. Y bueno, nos confeccionamos un PowerShell script que bueno, a día de hoy está funcionando en producción y en todos estos entornos nos está pues más o menos el que estimé 1.650 horas de computación al mes. Es dinero. Al final, después de lanzar ese script, en el momento valle, como podéis ver aquí, que empieza a las 8 de la noche, UTC, nuestro script empieza a desencadenarse y empieza a apagar máquinas. Y acabamos el periodo más bajo con 11 máquinas apagadas. Probamos también las Virtual Machine Scale Sets. Tenemos esta tecnología implantada en producción. lo configuramos y lo mantenemos con imágenes confeccionadas por Packer, pero se pueden utilizar directamente con las imágenes que disponemos de Azure. ¿Qué nos ha aportado esto? Pues que nos hemos quitado un montón de trabajo con las actualizaciones, por ejemplo en entornos Linux, cuando al siguiente mes preparamos una imagen con Packer, la probamos y automáticamente se la metemos al Virtual Machine Scale Set y ya hemos actualizado ya el sistema Linux. También con el Windows. Nos hemos quitado en mayor parte el WSUS. ¿Y cómo funciona el Virtual Machine Scale Set? Pues más o menos como las web apps. Tiene una parte de scaling, donde tú le especificas qué acción quieres hacer y cómo quieres que lo hagas. Y en este ejemplo, en base en porcentaje de CPU, cuando pasa el 75%, pues empieza a incrementar instancias. Es solito y automáticamente con nuestro código. Y lo mismo pasa cuando el porcentaje de CPU es menor del 25. Empieza a quitar instancias. Esto, la verdad es que nos da una tranquilidad a la hora de tener picos fuertes de tráfico. Nuestro futuro, pues esperamos descender nuestro gasto en Azure y controlarlo más todavía, pues yendo a tecnología de Kubernetes. En este caso estamos con ACS, pero iremos con AKS dentro de nada, en cuanto Microsoft lo libere. Y bueno, tenemos un trabajo muy fuerte que es pasar todo nuestro código a .NET Core, pasarlo luego a imágenes Docker y luego desplegarlo en Kubernetes. Básicamente aquí esperamos bajar el número de máquinas y más o menos un 30% de lo que estamos actualmente gastando. Y esto es todo. Gracias por atender esta presentación y bueno, si tenéis alguna pregunta. Alberto. Venga.
Ha dicho que los scale sets preparáis las imágenes con Packer, entonces cada vez que alguien despliega una aplicación creáis una nueva imagen y así la imagen ya va con la aplicación desplegada.
Sí. Tenemos, en el caso del Virtual Machine Scale Set, se ha cambiado lo que son los pipelines de desarrollo. Dejamos unas imágenes base, que la llamamos nosotros, preparadas todos los meses con las actualizaciones. Luego el equipo de desarrollo tiene su imagen customizada con Puppet, en nuestro caso. Ya la tiene provisionada en base a la base de la imagen. Y el último paso, que es cuando ya el equipo de desarrollo inyecta el código, ya se calienta esa imagen y es la release que va a los entornos.
Vale, has comentado que han aplicado diferentes estrategias apoyados en diferentes incluso herramientas para reducir el coste, ¿no? y analizarlo. Pero muchas veces el problema lo tenemos cuando queremos reportarle, por ejemplo, al CEO de la organización, cómo se ha transformado el coste que están pagando mensualmente de Azure. Me explico. Tú necesitas herramientas de reporting adecuadas para la gestión de la dirección con respecto a por dónde se están yendo los costos. Mencionaste Cloudin. A mí me parece una porquería, honestamente. No sé si alguien trabaja en Cloudin, pero es una auténtica porquería. Y hay otras herramientas de dashboarding que me parecen bastante incompletas. Yo he explorado la solución Adobe y es la única que he conseguido más o menos para sobrevivir. No sé si tienes alguna recomendación o alguna experiencia para eso.
You follow me, no, in English? Yeah. No, we've been working with Cloud Health, as I showed you, not Cloudin. Cloudin we investigated in. Later we thought that we were going to move to Cloudin maybe because of the move to Azure, of course, that it was implemented by Azure also. But we're still working with Cloud Health. What we do is we generate automated reports, but they're mostly based on daily reports. So what we do is we report the daily cost or the monthly cost to different key holders, so to the financial department or to different managers that are responsible for a certain part of the area. The end of the month reporting that we do, I think that you're referring to that because that we do ourselves. So our operations team is responsible to make the end of the month reporting to management. That we do based on Cloud Health, but based on the tags, we pull out all the information that we need. So we have everything in a list right away. With one click, we know right away which areas management want to see. And for that, we of course have our own document or Excel or whatever solution in which we implement it. So what we do is we copy it from there and we put it in our own system. And that's what finance, or at least the management, can see then. And there we check the flow of their day. At least they check if it fulfills their expectations in that sense. And we can take actions also. But there's still some manual work involved there. It's not like that we go in and we see right away what we want. They could, but at the moment we're not that prepared for that yet. So, but for us, Cloud Health so far, based on tags, you can create perspectives, which is just like a filter. So you select, I want to see it based on teams or based on product, and we see all the products. We get the cost for the end of the month from the product, and we pass it to management. So it will take half an hour of work, yeah, to get it. They could also go there themselves, of course, but
Okay.
I'm recorded.
No me ha quedado muy claro, no he entendido bien. Si tienes una serie de recursos en Azure que quieres de testing o para desarrollo y los quieres tirar los fines de semana o por las noches, si eso lo hacéis con scripts vuestros propios basados en tags, o Azure tiene algo...
No, a ver, Azure te provee, tiene una parte cuando entras en una máquina de auto shutdown, pero no controlas el arranque de esa máquina.
O sea, te la apagas sola, pero no...
Sí, se la apaga, pero alguien tiene que ir y darle a arrancar. Lo que hace nuestro desarrollo, que es más o menos basado en el runbook que hay en el portal de Azure, mira ese tag y coges esas franjas de horarios o los días de la semana que le pongas, porque le puedes poner Monday y el lunes está apagado. Y en base a ello, él hace todo lo que necesita, en base a ese tag. O sea, se recorre todas las máquinas y va leyendo esos tags.
Yeah, and what we
De
do,
eso que también está en modo paralelo, porque ataca de golpe a lo que le pongas, por ejemplo, 50 máquinas, en bloques de 50, va por 50 máquinas, revisa esos tags y si tiene que hacer una acción, le lanza el start o el stop.
what we do is, maybe you're referring to that also, that who owns that, you might want to know, no? Like who decides when a machine comes up or to go down also. So what we do is, we have everything set up automated in ARM, so all the code is in ARM, so also the tags we set with ARM. The teams themselves are responsible for when they want to have their machines up. So we give the power to the teams in that sense. We tell them, if you want your machines to come up at 8 in the morning, you set the tags for 8 in the morning. And if you want them to run on a Saturday because you want to do works on a Saturday, you need to change your tags and make sure that your machine is running on a Saturday and edit the tags. So they make the pull request with the values that they want. So they say, I want my machines from 7 in the evening to 7 in the morning shut down, but then I want to work on them. They make a pull request, we approve it if it's okay, and it goes automatically to the environment.
También previene, por ejemplo, en el entorno de desarrollo está todo el rato corriendo ese script, ese web job. Previene que cualquiera que tenga privilegio sobre el portal te despliega algo a mano y te lo deje ahí. Imagínate, te corre una máquina DS12 o DS14 a 3.000 euros el mes y te hunde. Entonces, si no sabe que está eso, automáticamente al de media hora o
when the script
como
runs.
te caiga el schedule del web job,
Sí.
te la va a pagar.
¿Y eso funciona no solo con máquinas virtuales, sino con algunos servicios PaaS? ¿Rollo web apps o base
Yeah, but with web apps, for example, if you shut them down, you still generate costs. So it's not interesting to do it with them. It's only interesting at the moment with the virtual machines, because then when you deallocate them, so remember, not stopped but deallocate, because when you stop them, you're still generating cost. Then you start saving money. At least then you start not generating money.
But you
or cost.
can scale down by using Roombox and PowerShell.
You can scale down, yeah.
Stop, just shut down, but you can scale down.
That you could do, yeah,
Sí,
indeed. Yeah.
ahí le podrías poner lógica tanto para Cosmos DB como Web Apps o Redis. Podrías hacerte tu lógica y implantarle que haga por medio PowerShell o por AZCLI que crezca o crezca.
Sí, pero es cierto que sean siempre lógicas de escalado hacia abajo y no de apagado porque te lo van a cobrar.
Yeah, but what they're saying is, what they're referring to is that you can scale down, which means that instead of using, for example, 8 cores, you will use 4 cores, not in the VM, but in the service, because a web app is at the end is also a virtual machine, but they call it web app in that sense. So instead of using a web app that costs you 160 euros, you will start using a web app that only costs 40 euros for the night, for example. So you save, that's what you were saying.
The best choice is Azure function.
The functions, yeah.
Bueno, ¿alguna pregunta más?
Sí, con vuestra experiencia, ¿cuáles serían los pasos que recomendarías para una empresa que quiere moverse a Azure? O sea, a nivel general, ¿cuáles deberían ser los pasos a seguir de manera resumida? ¿Qué deberían mover primero y luego?
Bueno, mover. Alberto, te puedo decir como transfuga. Nosotros empezamos en septiembre de 2015 a preparar todo lo que era la migración y en noviembre de 2015, en una semana, preparamos todo y ya pusimos un entorno, el de Estados Unidos, funcionando. ¿Qué hacer para moverte a la nube? Ha dado antes una charla muy buena Daniel Matei, que hablaba sobre esto. Y la verdad es que lo primero es analizar qué es lo que tienes en tu entorno on-premise. Y luego ver cómo de fácil o cómo de difícil lo vas a tener a moverte al cloud. Nosotros hicimos un trabajo muy fuerte en Puppet. Automatizamos, con ayuda de este señor, automatizamos un montón de trabajo. Prácticamente el 90% de las cosas estaba automatizado, salvo un clúster de SQL Server tradicional que está corriendo ahora mismo en Azure, todo está automatizado.
Cost related, I would say, I would definitely go with whatever kind of management tool you can find, but put something, make something there, configure something or some scripts that call to the API from Azure to get the cost or something, some periodical reporting. I think it's really important, and that's what the lag was of our company, that there was nothing in place. They were growing so quick that it just got out of hands. No one was following the cost. It was just, let's pay it and we go for it because we're growing. But no one really knew where we were spending the money. We even had a month that we were spending 30,000 euros because one team created something that they were not using and they forgot about it. And it was 30,000 euros that we paid that month just because we didn't have the control. So, and after that part is when we said, okay, this is the limit, and now we start working on this. Yeah, definitely.
¿Uno más? Regalamos, ¿eh? Tienes la tuya también. Bueno, pues muchas gracias.
Gracias.